Right. So Crookes use the sealed glass tube, then in that one, at the two ends, place two metal plates, apply a high voltage. Right. And when reducing the pressure inside this one, using a center opening, right, gas inside that one, gradually take to the outside. So under very low pressure condition here, under very low pressure condition, right, negative metal plate, we say that one as the cathode, this one is the anode. So starting from the cathode and towards the anode, starting from the cathode and towards the anode like this way, right, identify a beam of rays. Okay. When these rays fall on the glass wall here, right, he observe a green glow actually with that one. Initially identify that one, a green glow, right? So that rays, beam of rays, that one start from the cathode and move towards the anode. Because of that one, Crookes called these as cathode rays. Crookes called these as cathode rays. Right? So you learn that one. Cathode rays start from the cathode and move towards the anode. Call that one as the cathode rays. So only thing did by the Crookes, William Crookes, is this one. Crookes discovered the cathode rays. Right? Simple idea, right? A sealed glass tube, two metal plates placed there. Okay, then apply a high voltage and pressure reduce inside this one. At a very low pressure condition, this thing happen. Okay. Then after that one, right, scientist called Thomson. Thomson, J. Thomson. Thomson wanted to study further about these cathode rays. Okay, Thomson did experiments related to these cathode rays. By doing experiments, he able to discover some special properties. Right, number of properties discovered here. Actually, finally, right, we identify these are small particles actually, right, pass into one direction. Those small particles are negatively charged. And finally, we reach to this place, that is these cathode rays, right, they produced by the electrons, negatively charged particles, electrons, like that way. Okay. If electrons flowing like this way, pass like this way, actually whether we can see the electrons, no, it is not possible. But inside this one, a gas, right? Some sort of gas inside this one, hydrogen, no helium, or like that way, a gas. Because of the gas, right, we can see the right movement of these beam of rays from this one to this one, right? We can see that one as a glow or a spark, right? Viduli pulungu appaina right? A spark like that, we can observe that one because a gas is inside that one. Then, right, while moving the electrons here, right, actually, those collide with the gas atoms, then atoms excite and again when they are coming to the earlier states, release energy. We say that one as, right, fluorescence like that way. With that one, we can see this, right, glow here, right, we can observe because of that one. If not, we can't see the movement of these rays because they are electrons, right? So no way to observe that one. But right, we can observe like that. Later I'll give a note for that one, right? So a beam of rays pass here, starting from the cathode towards the anode, that thing happen. Okay, because of that one, Crookes called this as the cathode rays. So Thomson, we want to start from that place, right? Thomson did experiments to search, right, the properties of these cathode rays. Okay, today we want to start from that place. සරලව සාරාංශය උච්චරයි. ගිය සතියේ අපි ගොඩක් වෙලා කතා කරානේ. right? අද කතා නෑ. දැන් පාඩම right. කියන්න තියෙන දේවල් ගොඩක් දේවල් කිව්වා මං. right. You had the topic properties of cathode rays, right? Properties of cathode rays. Experimental observation like that way you had the topic. අලුත් දරුවොත් ලියා ගන්න topic එක එතනට. Properties of cathode rays within a bracket experimental observations. Experimental observations. Right. Under that one, number one. Number one. First property, number one. Take down this one. Number one. Cathode rays move in or travel in. Cathode rays travel in straight lines. Cathode rays travel in straight lines. Travel in straight lines. Right? To confirm that one, Thomson used this kind of setup. Right? Cathode ray tube we prepared like this way. Right? Front wall, right? Imagine it is like this way, like a torch here. 3-dimensional, think about that one. Right? Front wall. This wall, right? This wall is zinc sulfide treated. Zinc sulfide treated. Apply the zinc sulfide layer there. Then the cathode here, right? When using the anode, right, they use a special type of anode, some sort of special one. What is that special character there, right? Metal plate, but that one, right, can't cut into a cross shape like this way. Right? Metal plate, prepare like this way, a cross-shaped anode. This one cathode, negative terminal, cathode here. Okay. This one, at that time period, they call this one as the Maltese cross. Maltese cross. Okay. Anode, positive terminal, this one. Negative terminal cathode, positive terminal anode. Cross-shaped anode. Arranged like that way. Then reduce the pressure and allow to, now this end and this end connect to the high voltage and prepare the cathode rays. Zinc sulfide plated here, zinc sulfide treated screen like that way, right? Front glass wall here, right? Then when cathode rays passing here, cathode rays pass into this side. Earlier, when they fall on the glass wall, I told you a green glow produce, green colored glow. There is a mark, right? Like that here, when the cathode rays fall on this one, this whole glass wall, right, produce a glow, right? We say fluoresce there, right? Fluoresce there, not glow there. Whole glass wall, right, glow there. Then cathode rays pass into this side with that one, the whole right glass wall glow there. But because of this anode, right in here, it produces a shadow. A shadow produced on this right glass wall. Okay, so a shadow produced here like this way. Then as the special thing, the special character of the shadow is right this anode prepare as a cross shaped with sharp margins and edges. Then when producing the shadow here, shadow also with the sharp margins and edges. Okay, shadow also with the sharp margins and edges. With that one confirm, these cathode rays are moving in straight lines. If they are not moving in straight lines, right, here we can have a shadow, but you cannot, right, observe a shadow with sharp margins. Sharp margins possible if they are passing in straight lines. So with that one confirm, cathode rays travel in straight lines. Okay. Now these cathode rays, I told you, these made out of electrons or finalized like that way. We finalize, right? Finally, we identify these are electrons. Because of that one, now in here, if you take a magnet into this place, if you close a magnet here, right, path of this change. If you take a magnet into this place, again take to the outside like that way, then in here, this one, always change its shape, right? We say here, the shadow dancing here, like that way, right? I kill no the no, right? Like that way, shape of this one change there. Okay, that means if they are moving straight lines, we can have the shadow with sharp margin. Not the shadow with sharp margins confirm, right? They are moving in straight lines. Understand? Simple experiment, right? So just listen to this one. ඔදට අහගන්න පුතේ ආන් ඉඳලා මේ රූපය ඔළුවේ හදාගන්න එච්චරයි. They will not ask to draw these like that way. Right? Even they will not ask, right, write the properties of cathode rays. කවදාවත් අහලා නැහැ. But you should have about the concepts. How to learn this one from the very first beginning. No? Therefore, you have to learn this, but right after learning that one, right, word by word, you don't have to remember this. එන පන්ති ඉන්නකොට හොඳට අහුම්කන් දෙන්න. තේරුණාද? හොඳින් අහුම්කන් දෙන්න. කියන දේ හොඳට අහගන්න. ගෙදර ගිහිල්ලා අද කරපු වැඩ ටික අද බලා ගන්න. එහෙම නැත්නම් අඩුම ගානේ හෙට වෙනකොට බලන්න ආය පන්තියට එනකොට බලාගෙන එන්න. ස්ටාර්ට් එක ගන්න කිව්වේ එහෙමනේ මං. ඒ වැඩි කරගන්න දැන් මං දිගටම දැන් එදා මං ගොඩක් වෙලා කතා කරානේ. දැන් දිගටම කතා කරන්නේ හැබැයි ඔයගොල්ලන්ට ඕන වෙලාවට උපදෙස් ටිකක් දෙනවා. එච්චරයි. ඔයලා ටික ඔයගොල්ලෝ හදා ගන්න ඕන. ඊට පස්සේ මං හැල්මේ උගන්වනවා. තේරුණාද? එතකොට ඔයගොල්ලෝ හදා ගන්න ඕන නිර්මාණය වෙනකොට ඔයගොල්ලන්ට උගන්වන්න පුළුවන්. ෆස්ට් ලෙසන් එකේ පුතේ කෙමිස්ට්‍රි ටිකක් අන්තිම හරිය තියෙනවා මුල හරිය තියෙන හිස්ට්‍රි එක. තේරුණාද? හිස්ට්‍රි එක තියෙනවා. රයිට්? හා. එහෙනම් මේ හරිය පාඩම ටිකක් මුල හරිය චුට්ටක් බෝරින් වගේ තියෙනවා මම ඒ ටික ඉක්මනින් යනවා. right? කොහෙවත් මගේ ඇරෙන්නේ නැහැ ඔයගොල්ලන්ට ඈ. Okay, we'll write this one. You have the first point there, cathode rays travel in straight lines. Then you draw this diagram. Under that first point, draw this diagram. Zinc sulfide treated glass wall produce fluoresce. Negative plate cathode, positive plate anode, Maltese cross, Maltese cross, shadow with sharp margins and edges. Sharp margins and edges. Zinc sulfide applied there, that is to have the fluoresce there, right? Glow, to produce the glow, right? Zinc sulfide applied there. If not, when fall on the glass wall also given a green glow there. But if zinc sulfide treated there, we can observe the shadow properly. That is why zinc sulfide applied, right? Sometimes in your school labs, right, these cathode ray tubes indoors, right here, zinc sulfide treated plate also use here to observe the cathode rays, right? මේ වගේ plate එකක් දාලා තියෙනවා. Then when pass into this side, right, we can see those clearly. ඉස්කෝලවල තියෙන lab එකේ තියෙන cathode ray tubes වල තියෙනවා මේ. Right? All right. Below this, right? Below this. When producing cathode rays, a shadow is produced shadow is produced with sharp margins and edges. Is produced with sharp margins and edges. With sharp margins and edges. Confirmed that the cathode rays travel in straight lines. Cathode rays travel in straight lines. Underline shadow with sharp margins and edges. Okay. Second point. Now they are moving in straight lines. Second thing Thomson want to study is this one. Now Thomson decide these move in straight lines. Then Thomson want to have idea, right, whether these cathode rays mean a type of energy. It is whether a type of energy or matter. Want to feel that one, a beam like that to observe it, but I don't know whether it's a type of energy like the light energy like that, whether a type of energy or a particle character is there. Want to check it. For that one, what he did, he placed, right, in between the cathode and the anode, he placed a wheel here. We say that one as a paddle wheel, like this way. In between the cathode and anode, say the cathode is here, cathode ray tube inside that one cathode. Then cathode rays move into one direction, like this way, towards the anode, right? Anode here, in the path of that one, place a wheel, like this way. At that time period, called that one as paddle wheel. Paddle wheel. Habal sakaya. Paddle wheel. Okay. Then in the cathode ray tube, inside the cathode ray tube, cathode here, anode here, in the path of that one, place this wheel and produce the cathode rays. Okay. When passing the cathode rays here, what happened? Right? Thomson identified this wheel turn to one direction, rotate to one direction. If we rotate to one direction, meaning of that one is not a type of energy. If If a light beam here, right now we to turn this one. So with that one, decide this cathode rays means some sort of particle character should be there. A matter is there. Right? So confirm that one. Okay. As the second point, they have write this one. Second point. Second property. Cathode rays are a beam of particles. Cathode rays are a beam of particles. Beam of particles. Particles having mass and kinetic energy. Having mass and kinetic energy. Under that one, right? A paddle wheel a paddle wheel is placed in the path of the cathode rays. Is placed in the path of the cathode rays. In the path of the cathode rays. Comma. Then it is observed. The paddle wheel rotates. The paddle wheel rotates. Paddle wheel rotates to one direction. Rotates to one direction. It confirms that the cathode rays consists of small particles. Within a bracket, right? Cathode rays have a momentum. Gamyatavak. Mass and a speed or the velocity, right? Momentum. Draw this one, simply draw it, that is enough. This one turn into one side. Cathode rays, paddle wheel turn to one direction. Okay. Then the third property. Now, right, these move in straight lines, identify that one. Then these are some sort of particles, aware about that one. Right, some sort of particles, small particles, confirm that one. Then as the next thing, right, they discover this. Right, after discovering these are some sort of particles, right, they want to check whether they are with a charge. They are neutral particles or whether they are charged particles. Want to discover that one. So for that one, Thomson prepare another setup. Right? In that setup, He arranged it like this way. Cathode ray tube. Right. Then the cathode here, anode here. As earlier, prepare the cathode rays, terminals connect to the high voltage and prepare the cathode rays. Cathode anode will take like that way. Then he placed two metal plates. Two metal plates, inside or outside, no matter about that one, right? Metal plates like this way, right? And apply a right voltage to that one. So this one is the positive plate, negative plate. Like that, they apply a electric field. Electric field. Right? Without supplying the current to these metal plates, when producing the cathode rays, they move in straight lines. Move in straight lines. But when supplying the current to this one, that means when in the presence of the electric field, identify the cathode rays, right? They attract toward the positively charged metal plate. Attract towards the positively charged metal plate. How we say that one as deflect. Deflect, right? Deflect the direction of positively charged metal plate. Earlier decide these are particles, right? Are those particles attract towards the positive plate mean they are negatively charged. Like that they confirm. So to confirm that one, they are negatively charged. To confirm that one experiment used, that is electric field. Using the electric field, confirm, right, they are negative particles. Right, in another way, they apply a magnetic field here. With a magnetic field also confirm these are negatively charged. Like that way, using two experiments, confirm these are negatively charged particles. Okay. Take down the third property. Third property, cathode ray particles, cathode ray particles are negatively charged. Cathode ray particles are negatively charged. Are negatively charged. Okay. On that one, simply simple E. Right, this cathode rays deflect to cathode rays deflect to the direction of deflect to the direction of positively charged electrode. Deflect to the direction of positively charged electrode. Electrode. Come on. When they are passing through, when they are passing through an electric field, when they are passing through an electric field, through an electric field. We'll draw this one. Now you draw it like this way. They change their path, right? Attract towards the positive plate. Okay? Electric field here. Electric field. As earlier, cathode and the anode. Cathode and the anode. Mark this as deflecting cathode rays. Deflecting cathode rays. Deflecting cathode rays. Right. ටිකක් වේගෙන් ලියමු දරුවනේ. ටික ටික ඔයගොල්ලන්ගේ වේගය හැදෙන්න එපා. රයිටින් ස්පීඩ් එක වැඩි වෙන්න ඕනේ. උපරිම ලකුණකට යන ළමයෙක් ගාව තියෙන එක ලක්ෂණයක් ඒක. හරිද? හැම අවුරුද්දෙම මට ගෝලියෝ ටිකක් ඉන්නවනේ මේ වගේ. උපරිම ලකුණකට යන. හැමෝම හිතන්න මමත් එහෙම කෙනෙක් වෙනවා. හරිද? ඒගොල්ලෝ ගාව තියෙන එක ලක්ෂණයක් ඒක මොකද්ද? රයිටින් ස්පීඩ් එක ටිකක් වැඩි වෙන්න ඕන. ගොඩ වැඩි වෙන්න ඕනේ නේ. right? ටිකක් හඩිසර වෙන්න ඕන අපි. Okay. Below this right. Because cathode rays deflect towards the positively charged plate. Deflect towards the positively charged plate. It is confirmed that cathode ray particles are negatively charged. Cathode ray particles are negatively charged. Okay? Simple B. Balanapati. Now in second experiment they did this one, that is instead of the electric field here, right, place a magnetic field. Instead of the electric field, a magnetic field. Okay. Imagine it is like this way. Magnetic field. Right. So produce a magnetic field here and then prepare the cathode rays. Now what happened? Again cathode rays pass through the magnetic field. When passing through the magnetic field, observe. Right. Another thing. What happened there? Right. If consider this one, right, cathode rays now for the moment, right, for the moment, these cathode rays mean negative particles, no? Or in another way later, electrons. Okay. Negative particles are moving to one direction. Negative particles are moving to one direction mean it is like the opposite of the electric current. Electric current, right, in all levels you learn, right, positive current. We learn like that way. So, electrons pass into one direction mean the opposite of the current. If positive particles pass into one direction, it is like the electric current. Think this is current, for example. If current there, right, and a magnetic field there, a current here, magnetic field here, then a force produced there. Balayak hadena. Force. Fleming's left hand law. So in chemistry, they will not ask the left hand law, right? But left hand law. With that one, what happened? Current and the magnetic field with that one, a force produced perpendicular to that one. Force produced perpendicular to that one. Because of that one, now say negative particles are passing here. With the magnetic field, the force come to the outside. Imagine like that way, perpendicular to that one. Okay, for force like this, then particles passing here, what happened? Because of the force, deflect, change their path, come to the outside. So we say, right in here, when the magnetic field is here, right, cathode ray particles deflect in a perpendicular direction, to the magnetic field. Deflect in a perpendicular direction to the magnetic field. Understand? Right? Now, negative particles come here, force act on that one with that one, deflect in a perpendicular direction to the magnetic field. Not attract towards the north pole or the south pole. Earlier, electric field in that one attract towards the positive plate. Here, deflect in a perpendicular direction to the magnetic field. Okay? That thing happened. Now, if I ask this one, right? Now here, that one deflect in a perpendicular direction. Whether that one confirm these particles are negative particles? Negative particles can confirm another? No. Why? Now, say negative particles deflect here. I told you when pass through the magnetic field, deflect in a perpendicular direction. Say negative particles pass here, deflect here. If positive particles pass here, if positive particles to the inside. So both deflect in a perpendicular direction. Therefore, when pass through the magnetic field, deflect in a perpendicular direction. If I say like that way, it doesn't confirm these are negative particles. Maybe negative particles or maybe positive particles. That means if charged particles pass through the sun deflection, possible. So how to confirm they are negative particles? How to confirm that one, right? Scientists consider this one. Non-negative particles, not inside this one. Say magnetic field here, right? Magnetic field separately. With the magnetic field, non-negative particles pass through that magnetic field. Then, when non-negative particles pass through the magnetic field, say they deflect to the right outside. Non-negative particles. These are non-negative particles. Magnetic field with that one. These come to the outside. We'll imagine like that way. Outside. Then same magnetic field place here. A magnetic field එක මෙතනට apply කරනවා. Okay. Then these rays also deflect to the same direction. These also deflect to the same direction. These also deflect to the same direction. Mean with that one confirm they are negatively charged. So when they are giving the MCQs, right, if they say, right, cathode rays when pass through a magnetic field, right, cathode rays when pass through a magnetic field, they deflect in a perpendicular direction. It doesn't confirm they are negative particles, right? Similar negative particles. Negative particles when pass through the magnetic field, where they deflect, cathode rays also deflect to the same perpendicular direction. Confirm these are also negative particles. Padily, right? ඉතින් මේවා මේ කරේ කොහොමද? right? practical එක ඒවා ඔයගොල්ලෝ හිතන්න යන්න එපා. තේරුණාද? simply take these, right? මේ points ටික විතරයි අපිට ඕන. මම ඔයගොල්ලන්ට ගිය සතියේ කිව්ව පුතේ මම ඔයගොල්ලන්ට ඕන weight එකට තමයි උගන්වන්නේ. තේරුණාද? සමහර තැන්වල ගොඩක් නැගතිලා උගන්වනවා, සමහර තැන් අපි ඉක්මනින් යනවා. අහන තැන් අහන්න නැති තැන් තේරුණාද? දන්නවා මම ඒ ඉඳ මේ බරට තමයි උගන්වන්නේ. ඕගොල්ලන්ට තියෙන වැඩි පවරන වැඩි මං කීවේ ගිය සතියේ පවරන වැඩි හරියට කරන්න. හරි? මාව ටිකක් අඳුර ගන්න ටික දවසක් යයි ඈ. හරිද? එහෙනම් කියන දේ අහලා මම වැඩ කරන්න කියලා කිව්වේ මුලින්. එමෙිට අපි වැඩි පටන් අරන් තියෙන්නේ. Okay. Simple B. Simple B. Cathode rays deflect. Cathode rays deflect in a perpendicular direction. Deflect in a perpendicular direction. Deflect in a perpendicular direction when pass through a magnetic field. When pass through a magnetic field. Pass through a magnetic field. Under that one, right? Cathode rays are allowed to pass through cathode rays are allowed to pass through a magnetic field, pass through a magnetic field as given below. As given below. Simply draw this one. How they deflect, difficult to mark that one, right? Not attract toward the south pole, right? Deflect. Just come to the outside or to the inside. So in chemistry, they will not ask in what direction. Only thing is they are perpendicular to the magnetic field. Only that thing. Okay. Below this one, right? It is observed. It is observed. Observed that the cathode rays. It is observed that the cathode rays deflect in a perpendicular direction. That the cathode rays deflect in a perpendicular direction. Deflect in a perpendicular direction to the magnetic field. To the magnetic field. Underline deflect in a perpendicular direction. It is similar to the deflection of It is similar to the deflection of any other negatively charged particles. Any other negatively charged particles. Therefore, it is confirmed any other negatively charged particles. Therefore, it is confirmed that the cathode ray particles are negatively charged. Negatively charged. Okay. Now listen here. After this, please, we learn the properties like this way. Right? One thing you learn, they are moving in straight lines. Straight lines. Second thing you learn, they are with a particle character. Third thing you learn, they are negative particles. Like that way. Right? පාඩම උගන්ලා ඔයගලන්ට සමරයිස් කර කර යන්න පුතේ. හොඳට ඔලුවට ගන්න කියලා දෙන දේවල්. ගෙදර ගිහිල්ලා පාඩම් කරනකොට පාඩම් කරලා ඉවර වෙලා කරනවාද මේ දවස්වල තව ඔයගලන් වෙනස් කරගන්න ඕනින්ද මම ටික ටික කතා කරනවා උගන්න අතරේ. පාඩම් කරන පිළිවෙල වෙනස් කරන්න ඕනේ දැන් ඔයගොල්ලෝ. O level ක්‍රමයට කටපාඩම් කරන්න එපා. තේරුණාද? වාක්‍ය පාඩම් කරන්නත් එපා. concepts විතරයි අපිට ඕනේ ඉන්න රූප විදියට pictures, right? You build a picture for this one. Cathode ray experiment කිව්ව ගමන් රූපයක් ඔළුවේ හැදෙන්න ඕන. Two metal plates, apply a high voltage, pressure reduce. Then starting from the cathode to the anode, cathode rays. ඔච්චරයි ඕන. Like that, how confirmed? They are moving in straight lines. When placed the voltage cross, a shadow produce. Shadow is with the sharp margins and edges. That's all. කරනවාද වැඩි සංකීර්ණ කරගන්න එපා. Right? අතු පාඩම් කරනකොට cathode rays move in straight lines. වාක්‍යෙම වාක්‍ය එහෙම පාඩම් කරන්නේ නැහැ. මේ method එකෙන් ටික ටික මිදෙන්න ඕනේ. Right? Like that way. they move in straight lines. පාඩම් කරලා ඉවරලා පුතේ S2 පියාගෙන පොඩි වෙලාවක් කල්පනා කරලා බලන්න. පාඩම ලස්සනට හිතෙන් හදන්න. අපි හිතෙන් පාඩම හදනවා කියන්නේ ඔයගොල්ලෝ මොලේට පණිවිඩ දීලා අපව ගන්නවා. ඇක්සස් වෙනවා හැම වෙලේම ඔයගොල්ලන්ගේ ෆයිල් එකට. තේරුණාද? අන්න ඒක තමයි කරන්න ඕනේ. So they are moving in straight lines. They are with the particle character, can turn a pedal wheel. Okay? And they are negatively charged. To confirm negatively charged, to confirm that one, use two methods. Electric field, also in an electric field, right, attract towards the positive plate. In a magnetic field, deflect in a perpendicular direction. Deflect in a perpendicular direction, not confirm they are negative particles, because positive particles also, right, deflect in a perpendicular direction. But some, right, negatively non-negative particles, how they deflect into the same direction, these also deflect. They are confirmed negatively charged. Okay. Now, after discovering this, right, Thomson able to do this thing, right? Actually, by measuring those deflections when applying electric field, how much deflect they are like that by measuring those like that way. Using mathematics, right? Thomson able to determine the charge divided by mass. We label that one as E divided by M. Thomson able to determine this one theoretically, right? Determine this one, that is E divided by M value of a cathode ray particle. Charge divided by mass value of a cathode ray particle. So charge divided by mass value of the cathode ray particle. Charge separately, mass separately, and take the ratio. No, not like that. This net value. Net value. E divided by M net value. Samasthage. Right? So E divided by M value able to determine this one. Charge divided by mass value of a cathode ray particle. Okay? Now, Inside the cathode ray tube, inside the cathode ray tube, they use different gases produce the cathode rays. Once it is hydrogen, once it is helium, like that, they use different gases and produce the cathode rays. And in all those cases, determine E divided by M value. Then they change the electrodes. Metal plates, once they are iron, once they are copper, like that, metal plates also change and produce the cathode rays. Like that, when doing that one, right, they identify always this E divided by M net value is a fixed one, constant. Charge divided by mass value of cathode ray particle is a constant. Confirm that one. So different gases use, that means different matter use. Different electrodes use, mean again different matter use. Right? No matter what is the, right? What are the electrodes used here? What's the gas inside this one? Always cathode ray particle in that one. E divided by M value or the charge divided by mass value. Identify that one is a constant. That means the cathode ray particle doesn't depend on the matter, type of matter. With that one, not change. Okay? With the matter, it doesn't change. Right? Thomson had the idea earlier. Stoney mentioned something that is, right, there must be a fundamental particle carrying the electricity and call that one as electrons. Call that one as the electron. So Thomson combined that idea with this one and the, right, cathode ray particle decide that should be a fundamental particle common to all matter. Because with the matter, when we are changing the matter, right, cathode ray particle, EOM value not change. It's a constant. That means it's a fundamental particle common to all matter. Decide that one. Then combine that idea with the Stoney's idea and Thomson called, right, these cathode ray particles are the electrons. Right? Call that one as electrons. Understand? So Stoney given the idea, so Thomson, by doing experiments, able to confirm the electrons. Experimentally proved by Thomson. Okay, sometimes for the MCQs you need these ideas, right? So experimentally cathode rays, cathode rays discover Crookes. Right? Electron term given, Stoney. Electrons experimentally proved, Thomson. We'll write that. පොඩි කතන්දරයක් වගේ කියාගෙන යනවා මම. right? එතකොට මතක ඉන්නවනේ ටිකක්. Later, paragraph එකක් ලියන්න පුතේ. Later, separately paragraph. Later, Thomson was able to determine the charge divided by mass. First in words, write it, charge divided by mass. Then within a bracket, E divided by M. Charge divided by mass. Value of a cathode ray particle was able to determine the charge divided by mass value of a cathode ray particle. Value of a cathode ray particle. He was used different residual gases. Antargata vayun. Different residual gases. Use different residual gases and different electrodes. Different residual gases and different electrodes. And determine the charge divided by mass value, E divided by M value. Determine the E divided by M value of a cathode ray particle. of a cathode ray particle. Thereby it is confirmed correct that one, correct that one. Ek kapan puti, iraking kapan. It is identified that it is identified that it is identified that E divided by M value identified that E divided by M value is always a constant. E divided by M value is always a constant. Take down that value also. E divided by M equal 1.76 10 to the power 8 coulombs per gram. 10 to the power 8 coulombs per gram. No need to remember this. මෙයා පාඩම් කරන්න ඕනේ. Right, E divided by M value for cathode ray particle. ප්‍රශ්නවල අහන්නේ එහෙම. හරි? Is always a constant. Next line. Therefore, it is decided. Therefore, it is decided that the cathode ray particle is a fundamental particle common to all matter. Is a fundamental particle common to all matter. Next line. Earlier, fundamental particle common to all matter. Next line. Earlier, Stoney given an idea about electrons. By combining with Stoney's idea, Thomson called these cathode ray particles. Thomson called these cathode ray particles as electrons. Okay? Underline කරගන්න Thomson electrons. Next, what happened? Next, now E divided by M value, charge divided by mass value, net value known. Later, another scientist called Millikan. Millikan did an experiment using charged oil drops. Charged aropita telbindu oil drops. Using charged oil drops, Millikan did an experiment. We say that one as Millikan's oil drop experiment. So Millikan's oil drop experiment, it is not with your syllabus. ඒක උගන්වන්න නෑ ඔයගොල්ලන්ට. Okay. Okay. But by doing that experiment, actually in that experiment, right, an electric field through that one allowed to fall charged oil drops. Usually they should directly pass or fall on this place. See, because of the electric field, they right change their path like that way. By measuring that one, right, finally Millikan able to determine the charge of an electron. Oil drop experiment, now it is not in your syllabus, so no need of that one. Millikan, by doing the oil drop experiment, able to determine the charge of an electron. Millikan charge of the electron. ඔච්චරයි මතක තියෙන්න ඕන. හරි? මං කියනවා පුතේ ස්ථිරයි. එන්න බය වෙන්න එපා. කියනවා ස්ථිරයි කියන්නේ. ඒ අවශ්‍යව විතරයි කියන්නේ. අවශ්‍යව කියන දේවල් හොඳට අහන් ඉඳලා පාඩම් කරගන්න. තේරුණාද? අනවශ්‍යව එතකොට පාඩම් හිටින්නේ නැහැ ඔයගොල්ලන්ට. එහෙනම් ඔයගොල්ලන්ට මහන්සිය අඩු වෙනවා. හැබැයි කියනවා පාඩම් කරන්න ඕන. තේරුණාද? එතකොට පාඩම හොඳට අහන් හිටියොත් තමයි ගෙදර ගිහිල්ලා ඔක පාඩම් කරන්නේ. right? එහෙම නොවුනොත් වෙන්නේ අර එදිනෙදා වැඩ කරගන්න නැතුව ඔයගොල්ලෝ මාසයක් විතර ගිහලා නෝට් එක කරන් පාඩම් කරන්න ගියොත් එතකොට highlight කරපු තැන් නෑ ඔයගොල්ලන්ගේ ඔළුවේ. මම නෑ එදාට ඔයගොල්ලන්ට ඒක කියන්න. එතකොට ඔයගොල්ලෝ කරන්නේ මොකද්ද? තියෙන ටික ඔක්කොම අරගෙන කටපාඩම් කරනවා. එතකොට ඕනේ ඒවායි අනවශ්‍ය ඒවායි ඔක්කොම කලවමට තියෙන්නේ. අනවශ්‍යව කියන්නේ පාඩම යනකොට අපි ඉගෙන ගන්න ඒ වගේ අහන තැන් ඕගොල්ලෝ හරියට දන්නේ නැහැ. දැන් මගේ ගින්නිල්ල විශේෂත්වය තමයි ඒක. මම හැම වෙලෙම ළමයින්ට කියනවා. පුතේ මෙතන අහනවා මෙහෙමයි අහන්නේ මෙහෙමයි අහන්නේ මෙහෙමයි අහන්නේ. තේරුණාද? තාම මම මේ කියන්නේ දැන් කෙමිස්ට්‍රි තාම හම්බෙන්නේ නැහැ කියලා. ඉදිරියට යනකොට ඕගොල්ලන්ට මම කියනවා පාස් පේපර් වල මෙහෙම අහලා තියෙනවා මෙහෙම අහලා තියෙනවා මෙහෙම අහලා තියෙනවා කියලා. තේරුණාද? ඒතර ඕගොල්ලෝ හොඳට අහන් හිටියා. ගෙදර ගිහිල්ලා පාඩම් කරනකොට දන්නවා ඇප්ලිකේෂන්ස් ටික දන්නවා. ඒතර ලස්සනට පාඩම් කරගන්න පුළුවන්. හැබැයි ඒකට පාඩම් කරන්න කල් මැරුවොත් කාලය ගත කරලා පස්සේ නෝට් එක ගත්තොත් එතකොට මේ කියපු තැන් highlight කරපු තැන් නැහැ. අන්න එතකොට තමයි ගැටලුව එන්නේ. එතකොට ඕගොල්ලෝ පොතම කටපාඩම් කරනවා. එහෙම කළා විභාග ලියන්න බෑ. හරි? Millikan, right, able to determine the charge of an electron. Now Millikan determined the charge of an electron. So charge of the net value known earlier, Thomson. Charge of the electron known with that one later able to determine the, right, able to calculate the mass of an electron. Understand? Asterisk mark. හරලකුණක් දාලා ලියා ගන්න. The scientist called Millikan. The scientist called Robert Millikan. Robert Millikan. Robert Millikan did an experiment. Robert Millikan did an experiment using charged oil drops. Using charged oil drops. And thereby he was able to determine the charge of an electron. Charge of an electron. Underline Millikan, underline charge of an electron. Using the charge, next line, using the charge within a bracket E, using the charge E, and the E divided by M values, E value and the E divided by M value values. Later determine the mass of an electron. Later determine the mass of an electron. Charge divided by mass, E divided by M equal, 1.76 10 to the power 8 coulombs per gram. Net value. Charge for the earlier sentence in that one, able to determine the charge of an electron. Millikan able to determine charge of an electron. එතන ළඟින් ලියා ගන්න බැරිද? E equal කලින් sentence එකේ අවසානයේ. Charge of electron before determine this one. මේක ලියන්න කලින් මේක ලියලා නම් ඔහම තියාගන්න ඊට උඩින්. Able to determine charge of an electron. Bracket එකක් දාලා ලියන්න. E equal 1.602 10 to the power minus 19 coulomb. 1.602 10 to the power minus 19 coulomb. Again, no need to remember this one. We have a lot of applications in your syllabus, right? But they will give this one also. Make a equivalent they know. In your paper, in the first page, top of that one, they will give you the values. Charge of an electron, right? Speed of or the velocity of the light. Universal gas constant, Avogadro constant. Outcome values they know. Right? Now we'll apply that one here. This is net value. Charge is 1.602 10 to the power minus 19 coulombs divided by mass. Sorry. Therefore, mass equal mass 1.602 10 to the power minus 19 coulombs divided by 1.76 10 to the power 8 coulombs per gram. Coulomb cancel per gram. Then we get that one to this place. Then we get the answer in grams. M equal. Okay. තේරුණා නේද? Net value is this one. E divided by M. E value is this one. E mean the charge of the electron. Mass need there. So you take this term here, this one here, like that. M equal. Okay. This one divided by this one. In itself, coulomb cancel. Per gram come to this place. We get the answer in grams. Okay. Value kaliya ganna. 9.1 mass equal 9.10 10 to the power 20 minus 28. 10 to the power minus 28 grams. In kilograms minus 31. Right. 9.1 10 to the power minus 28 grams. දහරින 28 වෙනි බලය. Extremely small. Right? Mass. Negligible mass. Later when labeling the electrons later. Right? අපි මෙහෙම label කරනවා electron. Charge we place here. Mass we place here. Like you symbolize the elements, atomic number, mass number. Atomic number mean in another way the charge and the mass. Atomic number, mass number, charge, mass. Like that is electron, charge, mass. So mass, we assume it is negligible mass compared to the protons and neutrons. Right? So with this one, I want to say this thing. Minus 28 with that one is a extremely small value. Negligible mass. Okay? Right. Now the electrons, all right. Electrons, all right. Them electrons, all right. So with that one, come to this place. Now scientists in this time period, scientists know this thing. Atom is a neutral particle. Atom is a neutral particle. They know that thing. But now, inside the atom, negative electrons. Negative electrons. Okay? Whole atom is neutral particle. But negative particles in that one. With that one, scientists start to predict. That means there must be positive particles also inside the atom. There must be positive particles inside the atom. One scientist called, right, Goldstein. 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 Okay. Goldstein give an idea. Inside the atom, there must be positive particles. So the person who given idea about the positive particles, that is Goldstein. Okay. Goldstein given that idea and he, right, actually practically able to prove that positive particles inside the atom. So for that one, right, arrange a setup. Actually, it is similar to the earlier cathode ray tube. But in that one, the cathode, he prepared that one with a special way. Right? Cathode, when using the cathode, he used a perforated cathode. Perforated, Siduru Sahita. Perforated cathode. With that one, actually, right, Goldstein able to confirm, right, another type of particles inside the atom, positive particles. All right. Next, we have that part. Limopy. In this time period, again as a paragraph, in this time period, scientists are aware, scientists are aware that the atom is neutral, that the whole atom is neutral, aware that the whole atom is neutral, whole atom is neutral. But inside the atom, negatively charged electrons. Inside the atom, negatively charged electrons. Therefore, therefore, gini kapan. Scientist called, therefore cancel that one and write scientist called Eugen Goldstein. Scientist called Eugen Goldstein. They have given an idea. Scientist called Eugen Goldstein. They have given an idea that there must be, given an idea that there must be positive particles. There must be positive particles also inside the atom. Must be positive particles also inside the atom. Next line. Goldstein did an experiment. Goldstein did an experiment using a perforated cathode. Did an experiment using a perforated cathode. And he was able to using a perforated cathode, and he was able to confirm the positive particles. Was able to confirm the positive particles. Within a bracket, right? Experimentally proved. Confirm the positive particles within a bracket. Experimentally proved. Close bracket. Inside the atom. Inside the atom. Experimentally proved within a bracket. And close the bracket and write inside the atom. He was able to confirm the positive particles inside the atom. Okay. As the next topic, right? Production of topic alien, production of positive rays. Production of positive rays. Production of positive rays. All right. Baranaputimi. In that setup, he used this kind of setup. Same as earlier cathode ray tube. Another simple experiment. අපිට දැන් සිම්පල් වුණාට ඒ කාලේ ගොඩක් වැදගත්. Cathode ray tube, right? Then anode here, positive terminal anode. He used the cathode in this kind of place. Cathode. Special thing is cathode made out of, right? Cathode made out of metal, right? In that one, some holes produced there. So we see that one is a perforated cathode. Siduru Sahita cathode, yeah, perforated cathode. So place the cathode in this place. Like this way. With the holes. Okay. Then negative terminal, cathode, produce the cathode rays. Cathode rays pass to this side. Like this way. When they fall on the glass wall, usually give a green glow. Cathode rays produce green glow. Okay. While producing a green glow, they are, right, Goldstein discovered, right, another glow given in the opposite end. In this region, he observed a red colored glow. Usually it is red color. Red glow produced here. Okay. When carefully observing and checking, right, identified, while the cathode rays are moving to this side, to the opposite direction pass another type of rays. To the opposite direction pass another type of rays. Those rays pass through these holes and come to this side like this way. Pass through the holes and come to this side. Reach to the glass hole and given the red glow. Same as earlier, prepare the cathode rays, green glow here, but a perforated cathode here. Okay. To the opposite direction, pass another beam of rays and they produce a red glow on the opposite end. Discover that one. Okay. Discover that one. So cathode rays here to the opposite direction, right? Another type of rays. Initially, these rays pass through these holes and pass to this side. Pass through the holes with that one, right? Call these as initially canal rays. Why say canal rays? Nala kirana. Nala kirana. Canal rays. Canal rays because they pass through the holes here. Okay. After discovering this one, later did experiments. Again, actually Thomson involved there. Apo Thomson involved. Thomson involved this place and Thomson did again further experiments and I discovered the properties of this canal rays. Same as earlier, allowed to pass through a electric field. Shadows produced here also. Then allowed to pass through electric field, right? Then magnetic field. With check whether it is possible to turn right paddle wheel. All this happened there. But identify the particles are not negatively charged. These particles are positively charged. That means in electric field attract towards the deflect towards the negatively charged plate. Then when pass through a magnetic field, how the electrons deflect? If the electrons deflect to the or the cathode rays deflect to this side, these rays they reflect to the opposite direction. Discover like that. With that one finalize these positive rays. These positive rays made out of or consist of positively charged particles. Like earlier, cathode rays consist of negatively particles, like that way here confirm. These canal rays consist of positive particles. After discovering that one, they start to say canal rays. Instead of that one, they start to say they are positive rays. Positive rays. So cathode rays like that, a positive rays. Confirm that one. හරිද? අපි යමු එතනට එනකම්. දැන් මේ හරියපතේ පොඩ්ඩක් කතන්දර විලාසයක් තියෙන්නේ. හරිද? මේ ටික ඉවර කරගන්නකම් පොඩ්ඩක් ඒකට සහයෝගය දෙන්න ඕනේ. නිදිමතේ ඉන්න එපා. තරුණාද? මේ ටික දැන් මෙතනින් එහාට යනකොට අපි තා ටිකක් මොඩල්ස් ටිකක් සංකීර්ණ වෙනවා. ඊට පස්සේ අපිට එනවා සාමාන්‍යයෙන් ඔයගොල්ලෝ නොදන්නා කොටසකට. හරි? ඒක ගිහිල්ලා ඉවර කරගෙන අපි අවසාන හරිය තමයි ටිකක් තියෙන්නේ atomic spectrums, quantum numbers ඒ හරිය තමයි ටිකක් ඔයගලන්ට concepts තියෙන්නේ. But after that one we pass the second lesson. ඒ ටික ඉවර කරගෙන අපි second lesson එකට ගියාම second lesson mean right lot of concepts there. ගොඩාක් සංකීර්ණ සංකල්ප ගොඩක් සංකල්ප පිරුණු පාඩම. සංකීර්ණ නේ? ගොඩක් තියෙනවා සංකල්ප. හරිද? ඊට පස්සේ අපි යනවා third lesson එකට. එතකොට තමයි calculations එන්නේ. හරි. ඒ හරියට එනකොට තමයි ටිකක් chemistry ටික අහුවෙන්න ගන්න. හරි. පාඩම් තුනක් කරනකොට ටිකක් පදන් වෙලා ඊට පස්සේ තියෙන්නේ මට උගන්වන්න. හරිද? සාමාන්‍යයෙන් උගන්වන්න පටන් ගන්නකොට අවුරුද්දක් විතර ගත වෙලා. ඒ කියන්නේ සැරට උගන්වන්න ගන්නකොට. ඊට කලින් පදම වැටෙන්න ඕන හරියට. තේරුණාද? හරියට ෆවුන්ඩේෂන් එක වැටුනේ නැත්නම් අපි හැලෙනවා. මං ගිය සතියේත් ඔයගලන්ට කිව්වේ. තේරුණාද? ඉන්න කියන දේ අහලා වැඩ කරන්න. එනවනම් දිගටම පන්තියට එන්න කිව්ව නේද? right. ඒ තීරණ හරියට ගන්න කියලා කිව්වේ ඒකයි. ඒතර ඒ තීරණ ගත්තු පිරිසනේ මේ ඉන්නේ. අපි ඒක ක්‍රියාත්මක කරගෙන යනවා. කාලයක් යනකොට ඔයගොල්ලන්ට තේරෙයි මොකද වෙන්නේ කියලා. හරිද? මුල සිට අගට එක දවසක්වත් පන්තිය මග අරගන්න නැතුව වැඩේ කරොත් ඔයගොල්ලෝ කරනවද? මං කියන පිළිවෙලට වැඩ කරනවා නම් නියත ඒකකට යනවා ඔයගොල්ලෝ. නියත ඒක. ඒක දෙකක් නෑ. හැබැයි කියන දේ අහන්න ඕන. ඒ කියන පිළිවෙලට වැටි කරන්න ඕන. ඔයගොල්ලන්ට වරදින්න පුතේ උගන්වන්නේ නෑ. කරනවද? කිසිම තැනක වැරද්දක් නැතුව ඔයගොල්ලන්ට විභාගෙට සූදානම් කරලා දෙන්න පුළුවන්. හැබැයි කියන දේ අහලා වැඩ කරන්න ඕන. හරි? අද දවසක් මෙතන ඊළඟ දවස් තව තැනක ඔහොම මාරු වෙවි දුවන්න එපා මම ඔයගලන්ට උපදෙස් දුන්නානේ. මං ගාවට පන්ති ආවේ නැතත් කමක් නැහැ. හැබැයි එක තැනක හරි තැනක ඉඳගෙන වැඩ කරන්න කියලා. ඒක තමයි ඒ ලෙවල් වල තියෙන ප්‍රධානම කාරණේ. නැත්තම් ඔයගොල්ලෝ ලොකුවට අසරණ වෙනවා පසු කාලීනව. තේරෙනවද? ඔකනේ අපි හැමදාම අත්විඳින දේනේ. හැමදාම අත්විඳින දේ සමහරලාට දැන් 27 පන්තියේ දැන් පුතේ පාඩම් 5ක් ඉවරයි. දැනොත් සමහරලාට අලුත් ළමයි එනවා හිටපු ගමන්. හිටපු ගමන් ළමයි 4-5 දෙනා ඉල්ල වාඩිනවා ඊළඟ දවසේදී නෑ. ඇයි නැත්තේ? දැන් මම එතන ඉන්න හරියේදී උගන්වන ශෛලිය මීට වඩා වෙනස්. එතකොට මම ඒගොල්ලන්ට බේසික්ස් දීලා ඉවරයි. දැන් මම මගේ ක්‍රමයට උගන්වගෙන යනවා. එතකොට ඒක අල්ලගත්තු ටිකට විතරයි යන්න පුළුවන් ගම. එතකොට බය වෙනවා පන්තියට ඉල වාඩි වුණාම. එතනින් එහාට ගමන යන්න බැහැ. එහෙනම් එක සතියේ ඉන්නේ. ඊළඟ සතියේ ඉන්නේ. තේරුණාද? ඉතින් ඕගොල්ලන්ට පුතේ සීනි බෝල ගණන් හදලා හරියන්නේ නැහැ. ඒ ඔලෙවනේ. හරිද? මේ පදමට හරියට උගන්ව ගන්න ඕනේ. එන්න මේ ඉගැන්විල්ල කරන්න රයිට් ස්ටාර්ට් එක හරියට අපි ගන්න ඕන. ඔගොල්ලෝ මාත් එක්ක එක දිගට යන්න ඕන. හරිද? එන්න මේ විශ්වාසය තියාගෙන වැඩ කිරීම අත්‍යවශ්‍යයි. මම කියවනේ විශ්වාස නැත්තම් පන්ති වාඩි වෙන්නත් තේරුමක් නැහැ. තේරුණාද? ඒ විශ්වාසයත් එක තමයි මේ ගුරු ගෝල සම්බන්ධය තියෙන්නේ. එතකොට මම කියන දේ විශ්වාස කරලා ඔයගොල්ලෝ කරන්නේ නේද? එහෙම වැඩ කරොත් නේ ඔයගොල්ලන්ට දිනන්න පුළුවන් නේ. Right. Production of the positive rays under that one. Goldstein paragraph. Goldstein Goldstein use a perforated cathode. Used a perforated, if one within a bracket, porous cathode. Inside the cathode ray tube. Inside the cathode ray tube. And prepare the cathode rays. And prepare the cathode rays. Prepare the cathode rays. There he was observed. There he was observed that the cathode rays move towards the anode. Move towards the anode, comma, fall on the glass wall, fall on the glass wall, and produce a green glow. And produce a green glow. A green glow. Full stop. Full stop. While producing the green glow in one end, while producing the green glow in one end, at the other end, he was observed. At the other end, he was observed a red glow. Observed a red glow on the glass wall. Red glow on the glass wall. When carefully observing, he was identified when carefully observing, he was identified another beam of rays move to the opposite direction Move to the opposite direction. To the opposite direction. Comma. Pass through the halls of the cathode. Siduru, halls. Move to the opposite direction, comma, pass through the halls of the cathode and reach to the glass wall. And reach to the glass wall. Full stop and right. Because these rays pass through the perforated cathode. Perforated cathode. They are known as canal rays. Canal rays. You draw this one. Draw this one. They are known as canal rays. Okay. Label this as perforated cathode. Perforated cathode. Canal rays within a bracket. Positive rays. Red glow, green glow, mark that one. Red glow, green glow. Below this one, right? Later, Thomson did further experiments. Thomson did further experiments to determine the properties of these canal rays. To determine the properties of these canal rays. They were identified that the canal rays consist of positively charged particles. Positively charged particles. Identified that canal rays consists of consists of positively charged particles. And continue that one, and start to say these as positive rays, and start to say these as positive rays. Starts to say these as positive rays. Earlier canal rays, discover the properties, they are made out of positive particles, discover that one, and later call those as positive rays. Harida. Right. As a subtopic, right? Formation of positive rays. Formation of positive rays. Formation of positive rays. We'll check how these positive rays form. Baranapatimi. Now cathode rays here. Cathode rays move into this side. Inside this one, some sort of gas. For example, say hydrogen, H2 gas. Cathode rays, when pass into this side, cathode rays mean in another way, the electrons, right? Those electrons hit with these hydrogen molecules, colloid with the hydrogen molecules. Inside this one, gas pressure reduce up to very low value. So under low pressure condition, hydrogen is there. Electrons hit with that one, collide with that one. Then what happened? H2 molecules, H2 gas, actually they atomize first like this way. Hydrogen atoms. Further collide the electrons on the hydrogen atoms here. Cathode rays mean electrons, so they collide with the hydrogen atoms. Then what happens? When hit with the hydrogen atoms, hydrogen gas, from that one, an electron release, H plus, electron release. Hydrogen atom on that one, right? Fall the electron, moving electron, hit with that one, from the hydrogen, release the electron like that way. Ionization taken place. Molecules atomize and ionize like this way. H plus ions produce. If the residual gas is H2, we can have H plus ions. If the residual gas is helium, in helium, single atoms, no, directly helium into helium plus, release electron. Like that, right, produce cations. While producing cations, electrons, they are no, those forming electrons also attract toward the positive plate, accelerating this side. That means with the cathode rays, they also collect. Cathode rays mean electrons, so these electrons also collect. Then what happens in this region? H plus ion, like that, positive particles produce. Okay, positive particles produce. Positive particles produce, where that one produce? In the gas region. In the gas region in front of the cathode. in this gas region in front of the cathode, produce positive particles. Now, if I draw the perforated cathode like this way, perforated cathode, imagine this one is the cathode, then the holes in that cathode, take like this way, okay. Then cathode rays pass into this side, like this way. Cathode rays start with the cathode, metal plate, start from that one. Gas particles fall on that one with that, say, for example, H plus ion, like that they produce. Cations produce. Okay. Now what happened? These H plus ions, like that, a positive particles, this metal plate this is cathode negatively charged. They accelerate into the opposite direction, so start to move into this side. Start to move into this side because it is a perforated one now. Earlier, as usual, cathode use, but in Goldstein's experiment, a perforated one use. When using the perforated one, observe the red glow here. Earlier red glow not here because no holes in this one, so now we to pass them to the reverse. Okay, early in Crookes experiment. Now, right here, this one is a perforated one. They are the forming cations. They are moving to this side through the holes, like this way. Through the holes, they move to the opposite direction. Discover those as actually the canal rays or the positive rays. Okay, forming cations in front of the cathode in this gas region, forming cations. They accelerate to the reverse or to the opposite direction and produce the positive rays. Terunada, later scientists able to determine the charge divided by mass value of positive rays also. Q divided by M, earlier electron to give that idea, I use cathode ray particle for that one, E divided by M. E, right? Because the electrons are there, so I use E divided by M like that way. Positive ray particles, for that one they use Q divided by M. We use Q divided by M. Charge divided by mass. Charge divided by mass. Okay? In here, තේරුණාද හැදෙන විදිය? How the positive particles produce? It's all right. So these particles move to the opposite direction, produce a red glow. Then I want to give you the property of that one. Now, here we consider Q divided by M value. Q divided by M value. Now earlier E divided by M value. E divided by M value is always a fixed one. When changing the gases, nothing changed there. Always E divided by M is a constant. But if I use hydrogen here, I can have the positive particle, that is H plus. If I use the helium here, I can have the positive particle helium plus. If I use chlorine, chlorine plus. Like that, a positive particles. Only one electron release there, right? With that one, plus one charge, with that produce the right cation, positive particles. With that one, different gases here mean, if I check the Q divided by M, what happened? Actually, the Q divided by M value is different. It should be Q charge plus one. It is all right actually. Here minus one, like that, a plus one here. Now charge is fixed, but the mass of the particles different. Hydrogen certain value, helium different value, chlorine different value, like that. They have Q divided by M value is not a fixed value for the positive ray particles. It depends on the residual gas. Residual gas. තෙරුණාද? Formation of positive rays. Under that one, right? You draw this one. Make This is the cathode, negative plate. Negative plate, cathode. These are cathode rays. Cathode rays. These are positive rays. Positive rays. මේ හැම එකකම අදහස විතරයි තියෙන්න ඕන. අවබෝධය තියෙන විතරයි ඕන. Alright? Then right. When cathode rays passing through the when cathode rays passing through the residual gas passing through the residual gas particles are ionized through the residual gas particles are ionized. Example, if the residual gas is hydrogen, gas particles are ionized, full stop. Examples, if the residual gas is hydrogen, put a semicolon there. In front of that one, write this H2 gas pass into 2H gas. Then H gas into H plus gas. H plus gas. An electron remove. Next line. If the residual gas is helium, again semicolon, and in front of that one write helium gas into helium plus electron. Next line. As above, below that, right? As above, therefore, positive ions are produced. Therefore, positive ions are produced in the gas region, comma, in front of the cathode. In the gas region in front of the cathode. Full stop. Because the cathode is negatively charged. Because the cathode is negatively charged. Is negatively charged. These positive particles start to these positive particles start to accelerate into accelerate into cancel current, accelerate towards the cathode, accelerate towards the cathode, towards the cathode. Full stop and right. These pass through the halls of the cathode, pass through the halls of the cathode, through the halls of the cathode, and they are known as the canal rays. They are known as the canal rays within a bracket positive rays. Known as the canal rays within a bracket positive rays. Positive rays. You understand that one, how the positive rays produce? Next topic. Next topic. Properties of positive rays. Properties of positive rays. On that one, right? Thomson did experiments. Thomson did experiments and he was able to discover the properties of positive rays. Was able to discover the properties of positive rays. Within a bracket, right? Using similar experiments. Using similar experiments did for the cathode rays. Similar experiments did for the cathode rays. Did for the cathode rays. Close bracket. Number one. As earlier, check with the shadow, right? Above experiments, right? Directly we take the properties, right? Right, in the path of the positive rays, place a metal plate with that one shadow produce like that way. So they can produce the shadows. Confirm they are moving in straight lines. Number one. Positive rays travel in straight lines. Positive rays travel in straight lines. Within a bracket, right? Cast a shadow. Cast a shadow with sharp margins and edges. Shadow with sharp margins and edges. Cast a shadow with sharp margins and edges. Close bracket. Bracket at the shadow with sharp margins and edges. Move in straight lines. Bracket එක දිරිවි අපි. හරි. Move in straight lines. Cast shadow with sharp margins and edges. හරි. Second point. Second point. They can move they can move a pedal wheel. They can move a pedal wheel. Pedal wheel within a bracket, right? They can move a pedal wheel. Positive rays. Positive rays consists of particles. Positive rays consists of particles. Can move a pedal wheel. Positive rays consists of particles. Third point. These particles are positively charged. Are positively charged. Particles are positively charged. Positively charged in that one. To the next line simply. When these rays pass through an electric field, they deflect towards the negatively charged plate. Deflect towards the negatively charged plate. Negatively charged plate. Simple B. When pass through a magnetic field, deflect in a perpendicular direction. To the magnetic field. Deflect in a perpendicular direction to the magnetic field. All right. Leave a line and write this one. Rula Kerala properties all right. Similarly as in cathode rays, charge divided by mass within a bracket Q divided by M. Value of positive ray particles are determined. Q divided by M value of positive ray particles are determined. හරි මේ බලන්න දරුණි. right තව දවසක් විතර යනකම් ওই ඉතිහාස කතාව යනවා ඈ. ඊළඟ දවසෙත් තව ටිකක් තියෙනවා. ඕගලන්ට පොඩි පණිවිඩ ටිකකුත් තියෙනවා පුතේ. ඕගලන්ට මේ මං ගිය සතියේ මං හිතන්නේ කිව්වද මන්ද මේ ක්ලාස් එකට සාමාන්‍යයෙන් සම්බන්ධ වෙන්න පුළුවන් ආකාර තුනක් තියෙනවා. අලුත් දරු තේනින්ද කියන්නම්. right. පළවෙනි එක තමයි physically right you can be here right. ඒක තමයි මං thoroughly advise කරන්නේ පන්තියේ ඉන්න කියලා. තේරෙනවද? දැන් ඕගොල්ලන්ට දැන් මේ දවස්වල තියෙනවා ස්පෝර්ට් මීට්. අදත් තියෙනවනේ ස්පෝර්ට් මීට් එකක්. දැන් ටිකක් අද ගිහිලා තියෙනවා කට්ටිය. ස්පෝර්ට් මීට් එකට. right. එතකොට ස්පෝර්ට් මීට් තියෙනවා වෙන වෙන වැඩේ දෙනවා මේ දවස්වල විභාගය කරා විතරයිනේ ට්‍රිප් යනවා නේද පොඩි පොඩි කාරණා තියෙනවානේ පුළුවන් තරම් පන්තියේ ඉන්න උත්සාහ කරන්න ඉදිරියේදී නම් කොහොමවත් මග අරගන්න බෑ මේ දවස් දෙක තුනට පොඩ්ඩක් එහෙම වෙනවා එතකොට ඔයගලන්ට ෆිසිකල් ක්ලාස් එකේ ඉන්න පුළුවන් පුතේ එහෙම නැත්නම් ඔයගලන්ට ඒ වෙලෙම දැන් හිතන්න හදිසි අසනීප දවසක් කියලා එතකොට ඔයගලන්ට එදාට ලයිව් ක්ලාස් එකේ ඉන්න පුළුවන් හැබැයි ඔයගොල්ලෝ ගෲප් එකට ඇඩ් වෙලා ඒ රෙජිස්ටර් වෙලා තියෙන්න ඕන ඒ ටික කරගන්න රයිට් ඔයගොල්ලන්ගේ තොරතුරු අරන් තියෙනවනේ ගෲප් එකට ඇඩ් කරනවා ඔයගොල්ලන්ව දැන් අද අලුතෙන් ආපු දරුවෝ ඒ තොරතුරු දීලා යන්න රයිට් ඒතර ගෲප් එකට ඇඩ් කරලා තියෙනවා එතකොට ඔයගොල්ලන්ට පන්තියේ එදාට දෙන්න වෙන්න බැරි නම් අසනීප තත්ත්වයක් වගේ වෙලාවකදී තේරෙනවද කම්මැලි තිච්ච වෙලාවට ලයිව් ක්ලාස් එකේ ඉන්න උත්සාහ කරන්න එපා තේරුණා දැන් පැය 3 පන්තියක් වුණාට පුතේ මම කියලා තියෙනවා මේ පන්තිය මම right later this Thursday class I will take to the Saturday 1 up to 5 is the fixed time තේරුණාද for the moment 26 group is there 26 පන්තිය තියෙනවා එතන ඒ පන්තිය right ඒගොල්ලන්ගේ වැඩ ඉවර කළා තමයි මම ඔයගොල්ලන් ගන්න එතනට බරපතලම කට්ටිය ඒගොල්ලෝනේ හරි විභාගය කිට්ටු ඒගොල්ලන්ට ඒගොල්ලන්ගේ වැඩ ඉවර කරනවා ඒතර ඔයගොල්ලන් ඉස්කෝලේ පටන් ගන්න කාලේ වෙනකොට මම ඔයගොල්ලන්ව ගන්නවා සැටර්ඩේ වලට. ඒතර පැය 4 පන්තියක්. මදි වුණොත් 4:04 වෙන්නත් පුළුවන් පැය. හරිද? ඒතර සාමාන්‍ය ලයිව් ක්ලාස් එක ඔන්ලයින් ඉනවා කියන එක අමාරුයි. එන්න පුළුවන් තරම්. ඔන්ලයින්ම දිගටම ඉන්න දරුවෝ ඉන්නවා. සමහර දරුවෝ එහෙම කරලත් හොඳට වැඩි කරගන්න අය ඉන්නවා. නමුත් ෆිසිකල් ක්ලාස් එකට එන්න පුළුවන් අවස්ථාවක් තියෙද්දි ඔයගොල්ලෝ ක්ලාස් එකේ ඉන්න. තේරුණාද? එහෙනම් ඒ ගැන සැලකිලිමත් වෙන්න. ලයිව් ක්ලාස් එකේ බැරිම වෙලාවකදී ඉන්න. එහෙමත් බැරි වුණොත් එහෙම අද ඔයගොල්ලන්ට රෙකෝඩින් එක බලන්න අවස්ථාව දීලා තියෙනවා. ඒතර ඔප්ෂන්ස් තුනක් තියෙනවා. ඔප්ෂන්ස් තුනක්. තේරුණාද? ඉස්සර ඔය මොකක්වත් නැහැනේ. එක පන්තියට ආවේ නැත්නම් ඊළඟ සතිය එනකොට දන්නේ නැහැ මොනවද වෙලා තියෙන්නේ කියලා. දැන් හැබැයි ඔයගොල්ලන්ට ඔප්ෂන්ස් තව වැඩිපුර දෙකක් දීලා තියෙනවා. ඒත් එක්ක අද දවසේ පන්ති ඔයගොල්ලන්ට මග ඇරුණොත් ඊළඟ සතිය වෙන්න කලින් ඒක බලලා නෝට් එක හදාගෙන තේරුණාද? අවබෝධ කරගෙන ඉන්න පුළුවන්. පන්තියේ හිටියා වගේමනේ. එහෙනම් ඒ අවස්ථාව තියෙනවා. එහෙනම් ඒක මගේ අරගන්න එපා. ඊළඟට රෙකෝඩින්ග්ස් ඊ සතිය ඇතුළත බලලා ඉවර කරන්න. මාසෙ පහුවෙලා ඊළඟ මාසෙ ඇවිල්ලා ගිය මාසෙ රෙකෝඩින්ග්ස් කියලා ඉල්ලන්න එපා. එහෙම දෙන්න බෑ. අවස්ථා තුනක්ම ඔයගලන්ට දීලා තියෙනවනේ පුතේ. මේ අවස්ථා තුන ප්‍රයෝජනෙට ගන්න. හරිද? පරණ රෙකෝඩින් කියලා ඉල්ලන්න එපා. දැන් මේ ඔය අලුතෙන් එන ළමයිත් සමාජලාට එහෙම කරනවා. මාස ගාණක් ගිහිල්ලා ආපහු එනවා. ඒ එනකොට තනද පාඩම් දෙක තුනක් ගිහිල්ලා දැන් 27 පන්ති එහෙම එනවා. පරණ පාඩම් දැන් මම 6 වෙනි පාඩමත් පටන් අරන් තින්නේ. මේ ගිය සතිය වලත් ඇහුවා. සර් පළවෙනි පාඩම් තුනේ රෙකෝඩින් දෙන්න බැරිද? රෙකෝඩින් පැය මං හිතන්නේ ගණනය කරන්න බැරි ගාණක්. තේරුණාද? දවසකට පැය 3 ගාණක් කියමුකෝ උපරි අවමිය සති කොච්චරක්ද පාඩම් තුනක් කියන්නේ. ඒතකොට දෙන්න බෑ. එහෙම දුන්නද වැඩකුත් නෑ බලන්න කාලයක් එන්නේ. තේරුණාද? එහෙනම් මගේ අරගන්න එපා පුතේ. මේ සතිය ඇතුළත මේ වැඩේ ඉවර කරලා මේ දෙන උපදෙස් හොඳට පිළිපදින්න. ඒ සතිය ඇතුළත ඔයගලන්ට මගේ අරුණා නම් හදිසියවත් පන්තිය ඊළඟ සතිය එනකොට ඔයගලන්ට ෆ්‍රෙෂ් පිටේ එන්න පුළුවන්. මොකද පාඩම ඔයගොල්ලෝ දන්නවා. නෝට් එක ලියාගෙන සූදානම් වෙලා ඉන්න. හරිද? දැන් ඔන්න ඔය ටික මතක තියාගන්න. පුළුවන් තරම් පන්තියේ ෆිසිකල් ක්ලාස් එකේ ඉන්න උත්සාහ කරන්න. එතනත් දැන් මේ දවස්වල ඔය ක්‍රීඩා ආයෝම තියෙනවා, ස්පෝර්ට් මීට් තියෙනවා. ඒත් එක්ක මගේ අරිනවා පොඩ්ඩක් ඒක හරි. හරි. හැබැයි ඉදිරියේදී හැමදාම පන්තියේ ඉන්න උත්සාහ කරන්න. ඒක ඉතාම වැදගත්. හරිනේ. ඒක පොඩ්ඩක් මතක තියාගන්න. තර්ස්ඩේ ක්ලාස් එක සැටර්ඩේ වලට ගන්නවා කියන එකත් පොඩ්ඩක් මතක තියාගන්න. මං කිසිම හේතුවකට විපුතේ ඒ ටයිම් එක නම් වෙනස් කරන්නේ නැහැ. සැටර්ඩේ 1 up to 5. 5 වලට තියෙන්නේ මදි වෙනකොට 5:30 වලට යන්නත් පුළුවන්. හරි. එතකොට පොඩි බ්‍රේක් එකක් දෙනවා. මේක මේන් ක්ලාස් එක මේ තර්ස්ඩේ ක්ලාස් එක ඒක සැටර්ඩේ වලට ගන්න. ආයේ නයිට් ක්ලාස් එකක් තියෙනවනේ. ඒකේ සාමාන්‍යයෙන් 6-9 පන්ති යන්නේ. මදි වුණොත් 9:00 කරනවා. ඒකේ බ්‍රේක්ස් නැහැ මොකුත්. හරිද? තෙරුණානේ ඔය පන්තිය තමයි තියෙන්නේ. ඔච්චරයි තියෙන්නේ පන්ති. right? ඒ දෙකෙන් එකක්. පැහැදිලිනේ? ඒක පොඩ්ඩක් මතකේ තියාගන්න. ඉතින් ඔය groups වලට add වෙලා නැති අය ඒ ගැන පොඩ්ඩක් සැලකිලිමත් වෙන්න add වෙන්න group එකට. හරි? බලන්නකෝ. now determine the q divide by m. Determine the q divide by m. So q divide by m determine, right, when determining that one identified, it's different. Now with your knowledge also, now we know it is different. H plus, helium plus, Cl plus, like that. With that q divide by m is different. Right? Q divide by m determine. Q also known. Charge of electron, charge of a proton, like that is fixed value. Then with that they able to determine the mass also. Right? Different gases, when using different gases, when use different gases, Q divided by M is different. Identify that one. Then how they discovered the protons? the proton they discover this thing. When the residual gas is hydrogen, inside the tube, gas is hydrogen. Then the positive particle there is H plus. Positive particle is H plus. Okay. Then when changing the residual gases, different positive particles produce. They identify this one. Q divided by M value is not fixed, but when the residual gas is hydrogen, it produces the smallest possible positive particle. When the gas is hydrogen, smallest possible positive particle produced. Then they discovered when other gases are using here, their masses are multiples of the mass of the H plus. Smallest possible positive particle is H plus. And the masses of the other positive particles, they are multiples of this one. With that one, they have taken a decision that means H plus ion should be another fundamental particle. Smallest possible positive particle is H plus. Okay. Masses of others are multiples of this one. Now this should be the basic particle. Earlier idea given by the Goldstein. So Goldstein given the idea about a positive particle. Okay. So smallest possible positive particle is this one. Scientists call this one as another fundamental particle. Okay. With that one, scientists call Rutherford. Rutherford actually called his H plus as the proton. Proton, credit goes to the Rutherford. Positive particles, that idea given by the Goldstein. But the proton, discovery of protons, right, credit goes to the Rutherford. Okay. Smallest possible positive particle is this one. They discovered that one. With that one, say, right, that one should be a fundamental particle. Right, with that, Rutherford called this one as a proton. හරිද මේ අදහස? H plus is the proton. Exactly correct. Reason is, now when you consider a hydrogen atom inside that one nucleus, with your level knowledge, nucleus in this one proton. Then the electron, one electron. H plus mean this one remove. H plus mean, right, electron remove. Electron remove mean the remaining only the proton. H plus mean proton. Later in chemistry, right, in your syllabus, in right lot of places in learning inorganic, organic, right, I will say proton release. For example, acids, right, acids release a proton. Bases accept a proton, like that. Proton mean H plus. H plus. Understand? It is exact idea. පැහැදිලිද? ලියමු අපි. Separately, right? Determined. We stop there, no? Q divided by M value. Determined. Acha nama continue karan. Continue that one. It is identified. It is identified that the smallest it is identified that the smallest possible positive particle is produced when the residual gas is hydrogen. When the residual gas is hydrogen. Next line. Masses of the other positive particles are multiples of mass of H plus particle. Multiples of mass of H plus particle. Thereby it is concluded that the smallest possible positive particle within a bracket H plus should be another fundamental particle common to all matter. Another fundamental particle common to all matter. Next line with asterisk mark, right? Rutherford called this smallest possible positive particle as proton. Smallest possible positive particle as proton. Okay. Now electrons all right, protons all right. Okay. Balanapati. Electrons, protons, discovered those two. Earlier given golf ball model. So Dalton given the golf ball model. Now inside the atom, negative particles, positive particles identified. Okay. Negative particles, positive particles identified. With that, what happened? negative particles, positive particles inside this one. With that one, the earlier golf ball model or that idea rejected. Right? Now they want to have another new atomic model. For that one, right, Thomson again involved. Apau Thomson Madihat Tuna. Thomson given a new atomic model, right, for this one. With the electrons, protons, or with the negative particles, positive particles, a new idea. How he explained that one, right? He explained it like this way. Whole atom is a positively charged sphere. This one is a positive sphere. Simple idea, right? කවදාවත් මහන්නේ තොම්සන්ස් මොඩල් එක එක්ස්ප්ලেইন කරන්න කියලා. මේක කියන්න දෙයක් නැහැ. right? හැබැයි අපි දැනන් ඉන්න ඕන history එක. right? So it's a positively charged sphere. In that one, negatively charged electrons, electrons embedded, immersed in that, right, like this way. Positive sphere in that one, negative electrons immersed, ගිලිලා තියෙනවා එමෙතන embedded. Right? So at that time period when explained like this way, right, scientists identify this one like a pudding. තේරුණාද? ඒ කාලෙත් පුඩින් කාලා තියෙනවා. right? He identified or they identify this one as a pudding. In that one, these electrons like the plums. So they have called this one as the plum pudding model. So Thomson given the plum pudding model. Okay. Electrons, protons after that one given the plum pudding model. වාක්‍යය ලියන්නේ එක sentence එකයි ලියන්නේ ඈ. ඊට වැඩි දෙයක් උගන්වන්න නෑ ඕකේ. තේරුණාද? දැන් golf ball model explain කරන්න මේක explain කරන්න කියලා අහන්නේ නෑ පුතේ ඔයගොල්ලන්ගෙන්. හැබැයි අපි විකාශනීය දැනගන්න ඕනේ. තේරුණාද? එන්න අපි ලියාගෙන යනවා. right? එතකොට ගෙදර ගිහින් පාඩම් කරනකොට මම කිව්වා වගේ pictures තමයි ගන්න ඔළුවට. එතකොට පාඩම ඉවරයි. මුල විතරයි ඈ. තව පාඩම ඉවර නෑ. හරි. ලියමු අපි. New paragraph. After the discovery of electrons and protons. Dalton's atomic model was rejected. Dalton's atomic model was rejected. Next line. J.J. Thomson suggested a new atomic model. As given below. Right, this topic, plum pudding. Model, plum pudding model. Thomson underline කරන්න. Thomson. Under that one, right? Atom is a positively charged sphere. Atom is a positively charged sphere. Positively charged sphere. Comma. Negatively charged electrons. Embedded negatively charged electrons embedded in that positive sphere. In that positive sphere. Draw it. Sarlo Endagand. Positive sphere, mark it. Positively charged sphere. Electrons. Electrons. Okay. Next, what happened? Next, what happened? Now, in this time period, scientists know the charge, mass, charge, mass, charge of the electron, mass of the electron, charge of the electron, mass of the electron. Like that way, the charge of the proton, mass of the proton. They know that one. Experimentally, they determine. Okay, charges, masses known. In another way, scientists know, right, when you consider certain element atom, number of protons in that one, number of protons, electrons, away about that one. Scientists did experiments in different streams. Okay, pathological experiments kare. Right? Some try to identify how the electrons present in the atom. Some try to discover nature of the nucleus, like that way. So they know the charges, they know the masses. Then they know the number of electrons, protons in the atoms. Experimentally, they determine, say, for example, carbon. In carbon, 6 protons. 6 protons, 6 electrons. Know the masses of those. With that one, determine the mass of a carbon atom. Determine the mass of a carbon atom. Theoretically, determine that one. Mass of a carbon atom, theoretically. By doing experiments, determine the mass of a carbon atom. They identify a special thing. What is that? Experimental mass is considerably higher than the theoretical mass. In this time period, right, charges, masses known. So using the number of right electrons, protons, theoretically determine the mass, theoretical mass. Experiments with that determine the mass. Discovered or identified, experimental mass is considerably higher than theoretical mass. That means again a problem. What is that? Earlier electrons, protons, now whole atom is neutral. So electrons, protons with that, right? Confirm our same number of electrons, protons, then it become neutral. But mass wise, this one is different. So with that one, they have given another idea. What is that? Yes, inside the atom there must be another particle. There must be another particle. That particle should not contribute to the charge. Should not contribute to the charge, but should contribute to the mass. Should contribute to mass. Understand? Contribute to the mass, but no charge for that one. So uncharged particle inside the atom. Predicted that one. Okay. With that prediction, did the experiments. While doing the experiments, one scientist called James Chadwick. Scientist called James Chadwick. Chadwick able to discover an uncharged particle in the atom. He called that one as neutron. Neutron. Chadwick's experiment, again, it is not given in your syllabus. ඔයගොල්ලන්ගේ syllabus එකේ දීලා නැහැ. පරණේ වගේ දිගන්නවා. ඉස්සර oil drop experiment එකත් උගන්වනවා. Right? දැන් ඒව වැඩක් නෑ. But have to remember Chadwick discovered the neutron. Right? ආලුත් syllabus එකේ මට මතක හැටියට 19 paper එකේ පළවෙනි MCQ එක. හරි? 19 17 මට ගොඩක් වෙලාවට 19 paper එකේ වගේ මතක. First MCQ, right? Who discovered the neutrons? Like that. Right? Chadwick. එයින්ද ඔයගොල්ලන්ට පොඩ්ඩක් ඔය නම් මතක තියාගන්න කියන්නේ පරණ සිලබස් එකේ පුතේ නම් ඇහුවේ නෑ. right නම් අහන එක නැවැත්තුවා. ඊට වඩා අහන්න දේවල් ගොඩක් තියෙනවනේ. නමුත් right එකක් හරි ළමයින්ටත් ලකුණු ගන්න පුළුවන් වෙන්න කියලා. තේරුණාද? පළවෙනි question එකේ දෙවෙනි question එකේ ගොඩක් වෙලාවට first question second question right they ask with this right first lesson things right things included in first lesson atomic structure. අයින්ද මතක තියාගන්න ඕන Chadwick discovered the neutrons. right සාමාන්‍යයෙන් MCQs දෙකයි උපරිම තුනක්. අච්චර යන්නෙත් නෑ. දෙකක් විතර තමයි අහන්නේ පළවෙනි lesson එකකින්. හැබැයි ඒක ඉගෙන ගන්න concepts ගොඩක් ඕගොල්ලන්ට වටිනවා ඊළඟ පාඩමට යන්න. තේරුණාද? මේ concepts ටික මම ඊළඟට උගන්වනවා ඔයගොල්ලන්ට දැන් right how the electrons present and the electronic configurations then the nature of the right atomic orbitals like that further things. ඒ ඔයගොල්ලන්ට ඕනේ නම් second lesson එකට. හරිද? second lesson එකේ ලකුණු 100ක් තියෙනවා. Structured paper 100 marks. First question is from that one. Right? Chadwick did this kind of one. My experiment not take the right kare me wage deyak. Right? Chadwick. He used beryllium element right into that one, allowed to fall alpha radiation, alpha rays. Next day you can learn about the alpha rays. Right? Alpha particles. Right? Here it says beryllium into that one, bombarding, පහර දෙනවා. Right? Bombarding the alpha rays. Okay? When bombarding the alpha rays here, right? From this surface release an uncharged particle. Right? Using experimental setups, identify uncharged particles. The particles released here, they are uncharged like that. To confirm it. Right? That is how the right neutrons discovered. So this experiment did by the Chadwick, James Chadwick. Right? ඔයගොල්ලන්ට තියෙනවා nuclear reactions, right? Later, how to balance those, right? Simple nuclear reactions. Right? බරපතල ඒවා නෙමෙයි. In that place you can have this reaction also. මේක මං ලියන්න දෙනවා එතන. But they will not ask this one. මේක අහන්නේ. Only thing is neutron, Chadwick. ලියමු අපි. Point එකක් විදිහට ලියන්න පුතේ. In this time period, scientists are aware about charges and masses of electrons and protons. Therefore, theoretically, they were determined the masses of element atoms. Determine the masses of element atoms. It is identified that the experimental masses of element atoms are considerably higher than the theoretical masses. Considerably higher than the theoretical masses. Therefore, scientists predicted that there must be another particle inside the atom. Must be another particle inside the atom. Those particles highly contribute to the mass. But contribute to the charge. Sorry. Highly contribute to the mass, but not contribute to the charge. But not contribute to the charge. Not contribute to the charge. Next line. With this idea, scientists did experiments. With this idea, scientists did experiments and thereby scientists called Chadwick was able to discover an uncharged particle and called it as neutron. Okay. So electrons, protons, then the neutrons. Okay. Now electrons, protons, neutrons. Underline කරන්න පුතේ Chadwick neutrons. මතක තියාගන්න එක. Right. Next what happened? තව ටිකක් ඉදිරියට යමියොත්. Now electrons, protons, neutrons. Earlier plum pudding model, again, right, rejected that one. Because neutrons, how the neutrons present in the atom, right? Thomson not explained that one. Right. Next, what happened? Another new model expected there for that one, right? Further experiments did by the scientists, right? Then one scientist called, not one scientist actually, two scientists called Geiger and Marston, like that way, two scientists under the supervision of Rutherford did an experiment, right? With that one, right, they able to have a new idea about the atom. So with that, Rutherford able to give another model, right? We call that one as solar model of the atom. Solar model of the atom. Before reach to the solar model of the atom, now you have the electrons, protons, neutrons. Now you want to collect the properties of these, right? For example, charge, mass, like that way, those things, right? Want to collect that one as a table. Okay? As the topic, right? This one. Subatomic particles and their properties. Subatomic particles and their properties. Subatomic particles and their properties. Adega dona. පොතේ ඔයගොල්ලන්ට පොඩි පණිවිඩයක් තියෙනවා මේ දැන් ඔන්ලයින් ක්ලාස් එකේ ඉන්න අයටයි ඔයගොල්ලොත් හදිසියෙවත් අර මං කිව්ව හදිසි කාරණයක් හින්දා ලයිව් ක්ලාස් එකේ ඉන්න හරිය එහෙම නැත්නම් රෙකෝඩින් බලන්න යනකොට රයිට් ඔයගොල්ලන්ට වෙබ්සයිට් එකේ රෙජිස්ටර් වෙන්න තියෙනවා. ඒකේ ඩීටේල්ස් ඔයගොල්ලන් ගෲප් එකේ දාලා තියෙනවා. තේරුණාද දැන් අද ගෲප් එකට දාලා තියෙනවා කිව්ව බලන්න කොහොමද ඒකේ රෙජිස්ටර් වෙන්නේ කියලා. හදිසියෙවත් ඔයගොල්ලන්ට මේ වැඩේදී ගැටලුවක් ආවොත් තේරුණාද? මේ පන්ති බලන අංකල්ගේ නම්බර් එක දාලා තියෙනවා මේ අංකල් ප්‍රදීප් ඊට අමතරව IT වැඩ කරන්නේ ඉෂාර කියලා ගෲප් එකේ ඔයගොල්ලන්ගේ ජොයින් වෙලා ඉන්නවා කෙනෙක්. හරිද? ඒ දෙන්න එකතු වෙලා තමයි බලන්නේ. එතකොට ජොයින් වෙද්දි ගැටලුවක් ආවොත් කෝල් එකක් දීලා එකෙන් අහගන්න පුළුවන්. පොඩි වීඩියෝ එකක් දාලා තියෙනවා කිව්වා ඒ වෙබ්සයිට් එකේ රෙජිස්ටර් වෙන විදිය. හරිද? ඒක ඔයගොල්ලෝ පොඩ්ඩක් බලන්න. තේරුණාද? ගෲප් එකේ දාලා තියෙනවා. ගෲප් එකට ඇඩ් වෙලා නැති දරුවෝ අලුතෙන් ආපු දරුවෝ ඉන්නවා නම් අද ඩීටේල්ස් දීලා යන්න. ගෲප් එකට ඇඩ් කරගන්න. රයිට්? එතකොට ගැටලුවක් ආපු වෙලාවට මේ නම්බර්ස් දෙකෙන් එකකට කෝල් එකක් දීලා අහන්න. තේරුණාද? පොඩ්ඩක් හුරු වෙනකන් ඔයගොල්ලන්ට තේරුමක් නැහැ නේ. ඒ හින්දා එතකොට වෙබ්සයිට් එකෙන් තමයි ලබන සතියේ දැන් ක්ලාස් එකට එහෙම ජොයින් වෙන කෙනෙක් ඉන්නවා නම් ඔන්ලයින් ඉන්න දරුවෝ. අදත් මං හිතන්නේ රයිට් ලින්ක් එක දුන්නා. ඊළඟ දවසේ වෙබ්සයිට් එකෙන් තමයි ජොයින් වෙන්නේ. ලින්ක් එක දෙන්නේ නැහැ. එහෙනම් ඒ තොරතුරු ටික අරගෙන ඒකට සම්බන්ධ වෙන විදිහ බලන්න පන්තිය දැන් 2:00ට පටන් ගන්නකොට 2:25ට කෝල් කරන්න නම් එපා. ඔන්ලයින් ඉන්න අයටත් මම මේ කියන්නේ. කෝල් කරලා කොහොමද ජොයින් වෙන්නේ කියලා ඇහුවට මම 2:00 නම් 2:00ට පන්තිය පටන් ගන්නවා. තේරුණාද? සාමාන්‍යයෙන් මගේ හැටි එහෙමයි මං වෙලාවට කියන වෙලාවටම ඉන්නවා පන්තියේ. එන්න සාමාන්‍යයෙන් ඉස්කෝලේ හදිස්සිය වැඩක් යෙදුන්නේ නැත්තම් හරි ඒත් එනවා කොහොම හරි. හදිස්සියම කාරණේ විදිහට එහෙම වුණා මම පණිඩියක් දෙනවා ටක් ගාලා. නැත්නම් මං 2:30 වෙද්දි මෙතන ඉන්නවා. right සැඩේට ගත්තාම සැඩේදී 1 o'clock කියන්නේ 1 තමයි 1 කියද්දි මම මෙතන right උදේත් එමය 7:00 පන්තිය 7:00 වෙද්දි ඉන්නවා. එහෙනම් ඔයගොල්ලෝ පන්තියට වෙලාවට එන්න ඒවා හොඳ පුරුදුනේ නේද? එහෙනම් ඒවා හදාගමු. right ඉවර කරන වෙලාව ටිකක් ඉතින් එහාට ගියර කමන්නේ. දැනට මම නවත්තනවා 5:30 වලට නවත්තනවා. හරි? ඒක වෙනස් නෑ. හරි. එහෙනම් ඒ ගැන පොඩ්ඩක් සැලකිලිමත් වෙන්න පුතේ. right කොහොමද රෙජිස්ටර් වෙන්නේ කියන එක පොඩ්ඩක් බලන්න වීඩියෝ එක දාලා තිනවා කිව්වා ඈ. අපි ඩීටේල්ස් එක ලියන් යම් මේ ටිකේ subatomic particles and their properties. right prepare a table for columns හතරක table එකක් හදාගන්න. property electron proton neutron electron proton neutron mass. Mass of particle. Mass of particle in kilograms. හරිද? ලැස්ති. Property electron, proton, neutron. Okay. First property, right? Mass of particle in kilograms. These things not to remember. මේ මතක තියාගන්න නෙමෙයි දෙන්නේ, but some important facts are there. පොඩි පොඩි කාරණා ටිකක් දැනුවත් වෙන්න. Right? 9.107 9.107 10 to the power minus 31. 107 10 to the power minus 31. Then the proton 1.6725 10 to the power minus 27. Here 1.6742 10 to the power minus 27. With that one take idea, right? The heaviest particle in the atom is neutron. Podi venasai thiyenne, right? Usually we take right relative values when you are taking that one, we neglect this one. We assume that is 0. This one is 1, this one also 1 like that way. 1, 1 like that way. We take relative masses. But this one somewhat heavier than this one's. So heaviest particle is neutron. ඔය වගේ කාරණා කියන්නයි දෙන්නේ මේ නැතුව පාඩම් කරන්න නෙමෙයි මේක ඈ කට පාඩම් කරන්නේ. Right, just to aware. Right. Next line right here, relative mass. Mass here next the relative mass. Relative mass. Relative mass. Okay. So relative mass means we divide the mass by the mass of the proton like that way. We take like that way, right? Here relative mass when taking that one here, this one is 1 divided by 1840 approximate value. 1840. Here it is 1. Here also 1. Okay? Relative mass. Like that is next the charge. ඊළඟට ගන්න charge. Charge. Electron 1.602 10 to the power minus 19. 602 10 to the power minus 19. Charge here in coulombs. මෙතන ලියන්න capital C. Charge. Charge in coulombs 1.602 10 to the power minus 19. Proton also the same mass. Proton 1.602 10 to the power minus 19. Here no charge 0. Charge wise electron proton same, but they are opposite. That is why we say my right negative positive. ඒ කාලේ ඉලෙක්ට්‍රෝන එකට නෙගටිව් කිව්වා ඉන්න අනිත් එකට පොසිටිව් කිව්වා. තේරුණාද? ඒ කාලේ ඉලෙක්ට්‍රෝන එකට පොසිටිව් කිව්වා නම් ප්‍රෝටෝන එකට නෙගටිව් කියනවා. Right? Then the relative charge. Next. Relative charge. Relative charge. Relative charge. Under that one, this one is minus 1. This one is plus 1. This one is 0. Minus 1 plus 1 0. Okay. Then last you write here symbol. සංකේතය මම උඩින් ලියනවා. Relative charge below that one. Right? Symbol. How you label the electrons, protons. Symbol. Electron for that one we use the simple E. ආනපති right? When you make a dana දෙයක් නොගොල්ලෝ element, when you are writing element, here we write the atomic number, here we write the mass number, O level, atomic number, mass number. Atomic number give the idea of the proton. So here, atomic number, mass number, in another way, the charge and the mass. දැන් මේ විදිහට මතක තියෙන්න ඕන charge mass. With that idea, electrons in labeling that one, here we take the relative charge here, mass here, relative charge, relative mass. Sorry, 0. Okay? Charge mass. We label that one relative value. Right? So relative charge is -1. Mass, we take this one as the 0. With that one, 0 here. Okay? -1, 0. Then proton with that idea, simple P, simple N, බාන්න ලියන්න පුතේ. Proton charge plus 1, mass 1. So plus 1, 1. මේගොල්ලෝ ඔයගලට ඕන වෙනවා කොහෙදද? Later to balance the nuclear reactions. Nuclear reactions ලියද්දී. Plus 1, 1. අමතක වෙන්නේ නැහැ කොහොමද? Atomic number, mass number, charge mass. එතකොට අමතක වෙන්නේ නැහැ. Electron, proton, then the neutron, in writing that one, neutron, no charge. So it is 0 here, mass 1. Electrons, protons, neutrons. Okay? So 3 subatomic particles. So next day we can start with that one. Now, right? Thomson's Pampudi model rejected. Next what happened? Electrons, protons, neutrons with that new atomic model. ඔතනින් තමයි පුතේ අපි ඉස්සරහට යද්දී, right? Next the solar model of the atom, then the Bohr model, අන්න අතනින් අපි deviate වෙනවා පාඩම. Right? Then how the electrons present in the atom, like that way, new things. හරිනේ? ඉතින් ඔය ටික දැන් දවස් දෙකකින් අපි උතන්ට ආවා. ඔය ටික පාඩම් කරගෙන උතන තියෙන අවශ්‍යම කාරණා ටික පොඩි සමරි එකක් හදාගන්න. තේරුණාද? හරි. එහෙනම් අපි අදට නවත්තමු. අර කිව්ව කාරණා ටික මතක තියාගන්න. අර ඉස්සර වෙනා මේ ඔන්ලයින් පන්ති ඉන්න විදිය පොඩ්ඩක් අඳුන ගන්න. මොනවාරි අහන්න දෙයක් ගැටලු තියෙනවා නම් ඉඳලා අහලා යන්න. හරි පුතේ එහෙනම්. right. forms දීලා තියෙනවද? forms වගේ දීලා ඇති පුතේ අලුත් දරුවන්ට fill කරන්න. ඒ තොරතුරු ටික fill කරාද ඔයගොල්ලෝ? fill කරේ නැත්නම් fill කරලා දීලා යන්න. group එක හදා ගන්න. හරි. good evening to all. එන යන්න. හරි යන්න පුතේ යන්න.